So here's another problem out of, this is section 2.5, number 37, implicit differentiation of a pretty complicated function. They want us to find the slope, or let me see, is the equation of the line. Yeah, so they want us to find the equation of the line tangent to the point right here at this point, -4, 2, √3. So the equation of the line that's tangent to the curve and goes through that point. This is the equation. It's not a function, but it gives us this crazy, they call it cruciform. So we're going to differentiate it implicitly and solve for y prime, and then plug these values into the derivative to get the slope. Once we get the slope, we can work backwards and figure out y equals mx plus b, the equation of that line. That's parallel, that's tangent to the curve at that point. Okay, so let's differentiate this. This is going to start out being a product rule right here. So these are two functions multiplied together. So you have to look at that and say, oh, that's going to be a product rule. So we differentiate by differentiating the first function. So it's going to be 2x, and leave the second function alone. And then plus, now we're going to leave the first function alone and differentiate the second function. When you differentiate a y, though, with respect to x, you have to remember the chain rule. So every time you put a y, you differentiate a y, you put a y prime after it. So it's times y prime at the end. So that's the product rule for that first little function there. And I'm going to put parentheses around it, just to remind us that it is a product rule. They don't really do anything. We'll get rid of them in a minute. Okay, the rest of this thing, I'm going to differentiate this. It's just a pretty simple derivative, minus 18x. Differentiate this, it's again simple, 8y, but I differentiated a y, so I have to put a y prime after it, and that's going to equal 0. Okay? So let's differentiate in there. One product rule, a little bit complicated, and then these are pretty simple derivatives, so you just have to remember to put a y prime whenever you differentiate a y, because it's derivative, we're taking the derivative with respect to x. Okay? Now we're going to solve for y prime, so I'm going to get rid of these parentheses, they're not doing anything. And I'm going to get all the y prime terms on one side and all the non-y prime terms on the other. So I think I'm going to let's bring these two terms over to this side. They'll change signs when they go across the equals. So I'm going to have 2xy squared on this side, minus 18x, and that's going to equal 8y y prime minus x squared 2y. Let's write it 2x squared y y prime. Okay? So change the signs when you take it over the equal sign. Now we're going to factor out y prime. So I'm going to factor out the y primes here. So I'm going to get this. 8y minus 2x squared y, parentheses, and then a y prime outside, and it's still equal to this over here, no change there. Okay, 2xy squared minus 18x. And now you're just going to divide by this parentheses, and you'll have the derivative. So y prime is going to equal 2xy squared minus 18x all over 8y minus 2x squared y, and that's going to equal y prime. And you could factor 2 out of there, it looks like, and you could factor, you can't really factor, you could factor an x out of the numerator and a y out of the denominator, but that doesn't really look like it helps us much. So we could rewrite this if we wanted to. You know, we could rewrite it xy squared minus 9x all over 4y minus x squared y. Doesn't simplify it much, but maybe a little bit. So that's what y prime is equal to. So that's the slope at any point on this curve. We can put it in any x and y coordinates around the curve, and it would tell us the slope at that point. Pretty amazing. What we're going to do, though, is we're going to put in these points right here. I'm going to put in -4 and 2√3, so -4 for x. So let's see, what's that give us? That gives us -4. 2√3 squared is going to be 4 times 3, that'll be 12, minus 9 times -4, all over 4 times 2 root 3 minus x squared is going to be positive 16 times 2 root 3. I was hoping that was going to get a little simpler, but it doesn't look like it does, unless I've made a mistake somewhere. So we'll check on that, but I think that's correct. So let's see what we get when we do that. So let me do this on a calculator. So it's going to be negative 48 plus 36, right? Negative 48 plus 36. So that's going to be a negative 12, I believe. And then the denominator is 4 2 root 3 minus 16 2 root 3. So that's going to be 12 minus 12 times 2 root 3. That's going to be minus 24 root 3. So the negatives cancel there. You get a positive, which makes sense because we've got a positive slope. You can see by looking at it. And then we have 1/2, or 1 over 2 root 3 is going to be our answer. So the slope there, y prime, is going to equal 1 over 2 root 3. Okay? So our equation of this line is going to be y equals 1 over 2 root 3 x plus b. And what I'm going to put in here is I'm going to put negative 4 in for x. And I'm going to put 2 root 3 in for y. And let's see what that gets us. So let me erase this so I've got a little bit of room to work. So that's 2 root 3 here equals 1 over 2 root 3 and times negative 4 plus b. So if let's bring this over. So it's going to be negative 2 over root 3. So if I bring this over, I'm going to have this. I'm going to have 2 root 3. And then it's going to be minus, actually this is a plus, a minus here, so it's minus 2. So it's going to be plus 2 over root 3. And that's going to equal b. So if we simplify this a little, multiply by root 3 over root 3 here, get a common denominator. So it's going to be 2 times 3 would be 6 plus 2 would be 8 over root 3. So that's going to be b. So our equation, the equation of the line is going to be y equals 1 over 2 root 3 times x plus 8 over root 3. Okay? So pretty involved process, pretty involved problem. The difficulty, the tricky part, I think, is once you do the implicit differentiation, knowing how to get all the y prime terms on one side, and then factoring out that y prime. So that's the tricky part right there, and then dividing through, and that solves for y prime. Okay. So try that problem. It's a pretty hard problem. There'll be probably one problem like that on the test. So make sure you know how to do that.